Hi, I'm Anika Jha, and earlier this year, my family was almost evacuated during the Palisades fire, the most destructive in Los Angeles history. Experiencing this fear firsthand, watching smoke rise in the near distance and not knowing what would happen next, inspired me to dig deeper. I found that wildfires are becoming increasingly frequent and severe. In California, they can annually burn millions of acres and destroy land, forcing thousands out of their homes. The way we currently manage wildfires can be broken into 3 phases: before, during, and after. Before a fire starts, our detection methods rely mostly on lookout towers, satellites, and smoke sensors, which are helpful but often too slow, distant, or imprecise to catch fires early enough. During a fire, emergency crews are usually sent to approximate locations with limited prior data, which costs critical minutes and puts firefighters' lives at risk. And after a fire, communities face years of rebuilding, physically and emotionally. Yet, surveys show that nearly 60% of Californians still feel unprepared and confused about what to do when wildfires strike. So, I created Fire Up. Fire Up is an intuitive yet powerful web app that brings together prediction, live detection, actionable guidance, and evacuation planning in one cohesive experience, making wildfire readiness more interactive and accessible to both civilians and first responders. The homepage displays a dynamic prediction map for fire likelihood, acres affected, and severity, along with a live view of current fires. I spent over 100 hours using Python to collect and process data from NASA firms and app years, OpenMedio, and CAL FIRE. I then trained it with a light GBM machine learning algorithm, which provided the best balance of accuracy and speed against other algorithms to build a model that uses weather and land factors like temperature, vapor pressure deficit, wind, and vegetation to make predictions. The app fetches real-time data for regions of California, runs the models, and displays prediction results as a customizable and interactive Plotly heat map. The detection page brings real-time monitoring into the app. It connects to a Raspberry Pi 5 with temperature, humidity, light, and camera sensors, sending live data through a Flask API to Streamlit. My TensorFlow Keras convolutional neural network, trained to 95% accuracy, analyzes the feed to detect fire, smoke, or safe frames, showing how AI can flag wildfire risks quickly. This feature previews how autonomous drones could one day stream live data directly into FireUp. Until then, users can run my code on their own Raspberry Pi, input their Flask URL, and use FireUp to monitor their homes, turning it into a practical, scalable safety tool. The evacuation page produces optimized routes that avoid active fires using the GeoAppify API and NASA firms data. Finally, the Fire Guide provides a clear, comprehensive guide to wildfires, and the SOS page lets users quickly reach emergency contacts or community support. Fire Up is unlike any existing wildfire management tool. It combines multiple real-time factors to generate dynamic predictions, and unites several other features into one powerful, user-friendly app. It's modular, data-driven, and built to grow. Because the next time a spark ignites, we shouldn't panic. We should be ready and fired up.